Good afternoon. My name is Jillian Davies and I'm the moderator today. I'd like to welcome you to the Society of Wetland Scientists March 2019 webinar titled Wetlands in a Changing Climate, Science, Policy, and Management. I want to offer a special welcome to any non-member guests we have joining us today for our quarterly free webinar. All of our webinars are complimentary to SWS members, but once a quarter we open it up to the public. Our next free quarterly webinar will be held in June. Before we get started, I'd like to give our guests a quick overview of what SWS is all about. Since its founding in 1980, the Society of Wetland Scientists has continued to grow with more than 3,000 members from around the world. We have a diverse membership hailing from all sectors of wetland science, including a large sector of students. We're committed to providing our members meaningful resources that promote wetland education, conservation, and restoration globally. SWS membership includes full access to the Wetlands Journal, Wetland Science and Practice, and other professional journals, such as Wetlands Ecology and Management. In addition, SWS members enjoy discounted rates for the professional certification program, access to regional chapter and interest section activities, student programs and grants, and discounted registration at the SWS annual meeting, all of which provides members the opportunity to network with wetland professionals from around the world. Please visit our website at sws.org to learn more about becoming a member and our member benefits. We're proud to announce that this webinar has been pre-approved by the SWS Professional Certification Program and is applicable for continuing education credits. Participation certificates are now available through an automated process. You'll receive an email from SWS manager, Michelle Chozik, about a day afterwards. Check your spam email if you don't see it. These certificates are free to SWS members and are available for non-members for a nominal cost of $20. Participation certificates are also available for those who watch webinar recordings, which can be found on our past webinars page or the YouTube channel, complete with multilingual captions. So with the logistics out of the way, let's get started with the webinar. Again, my name's Jillian Davies, and today I'll be your moderator. Before going further, I'd like to go over a few housekeeping items. The general format for today's webinar will be two 20-minute presentations by our speakers, followed by approximately 15 minutes for questions. At any time during the presentation, you can type your questions into the questions pane. Please indicate to which speaker or speakers you are addressing your question, and I'll pose the questions to our presenters at the end of the presentations. The webinar is being recorded, and you'll receive a link to the recording following the webinar. We also ask you to take a moment to complete the evaluation survey that will help us plan future events. If you'd like a copy of today's slides, please find a PDF copy in the handout section of the control pane. And initially we had one with an incorrect webinar date on it, so we've just put up the corrected one. If you want to re-download it and make sure you have the correct date on it, that you might want to do that. If you're tech savvy, please use hashtag SWS webinar to tweet about today's webinar. And now let's get started. Professor Max Finlayson is the current SWS president-elect and the director of the Institute for Land, Water and Society at the Charles Sturt University in Albury, New South Wales, Australia. He's been a technical advisor to the Ramsar Convention on Wetlands since the early 1990s and serves as a visiting professor at the Institute for Wetland Research at the China Academy of Forestry in China. Max is a renowned wetland ecologist with extensive experience nationally and internationally in the science and management responses to water pollution, mining, and agricultural impacts, invasive species, climate change, and human well-being in wetlands. He's participated in global assessments such as those conducted by the Intergovernmental Panel for Climate Change, the Millennium Ecosystem Assessment, the Global Environment Outlook, and Water Management in Agriculture. He has been actively involved in environmental NGOs and science organizations and has worked with government, community-based organizations, and industry to investigate the causes of ecosystem change and management responses. Professor Finlayson has worked extensively on the inventory, assessment, and monitoring of wetlands, in particular in wet tropical, wet dry tropical, and subtropical climatic regimes, covering pollution, invasive species, and climate change. His current research includes interactions between human well-being and wetland health in the face of anthropogenic change, vulnerability and adaptation of wetlands and rivers to climate change, integration of ecological, economic, and social requirements, and trade-offs between users of wetlands, with an emphasis on developing policy guidance and institutional changes and landscape change involving wetlands and rivers and land use and implications for wetland ecosystem services and benefits for local people. Professor William Mumma is Emeritus Professor of International Environmental Policy and Founding Director of the Center for International Environment and Resource Policy at the Fletcher School of Law and Diplomacy at Tufts University in Medford, Massachusetts, USA. He currently serves as co-director of the Global Development and Environment Institute at Tufts, which he co-founded. He received his BA degree in chemistry from Williams College and PhD in physical chemistry from MIT. He had a 26-year career in chemistry and environmental studies at Williams College, where he directed the Center for Environmental Studies. He served as AAAS Science Fellow in the U.S. Senate, where he worked on legislation that successfully addressed ozone depletion and on legislation responding to the 1973 energy crisis. He began working on climate change in 1988 as the first director of the climate program at World Resources Institute in Washington. He's been a lead author of 5 intergovernmental panel on climate change reports. The IPCC shared the Nobel Peace Prize for its climate work in 2007. He's currently working on natural solutions to climate change with a focus on increasing carbon dioxide removal and storage rates by forests, wetlands, and soils to complement emission reductions from land use changes and fossil fuels. He chairs the board of directors of 2 climate science and policy organizations, the Climate Group North America and Woods Hole Research Center. He also serves on the boards of directors of the Nature Conservancy of Massachusetts, the Consensus Building Institute, Earthwatch Institute, and on the national advisory boards of the Union of Concerned Scientists and Young Voices for the Planet. He and his wife, Margot, completed a zero-net energy home in Williamstown, Massachusetts in 2007 that produces sufficient solar electricity to meet all of its heating, lighting, and appliance requirements while exporting surplus power to the grid. They've recently added more solar power panels for a battery-powered electric vehicle. Okay. Sorry, just a second, a little technical. Before Bill and Max get started, I thought I'd provide some context for their talk in an attempt to draw attention to the significance of the contribution that wetlands make to the global carbon cycle and potential carbon solutions, and to climate change adaptation and resilience, as well as to the threats that wetlands face in a changing climate. A group of wetland scientists has been collaborating with climate scientist Bill Mumma to tell the story of wetlands in a changing climate. The group came together as organizers and speakers at the 2015 SWS annual meeting. In joining this group of wetland scientists, Bill has contextualized our wetlands work into the broader climate change discussion, with the result that we've written several papers and articles and presented a symposium at last year's International Society of Wetland Scientists annual meeting in Denver as initial steps. Our first paper is Wetlands in a Changing Climate: Science, Policy, and Management, a comprehensive review paper that addresses all aspects of the relationship between wetlands and climate change, upon which this webinar is based. Max suggested the idea of a second paper written in response to Ripple et al.'s World Scientists Warning to Humanity, a second notice. Our second paper addresses wetland management and policy in light of the scientists' second warning to humanity. These collaborations are the direct result of efforts by the Society of Wetland Scientists to bring together leading scientists from around the world to address science, policy, and management pertaining to wetlands in a changing climate. Most recently, SWS hosted an event on climate change and wetlands at the Ramsar Convention on Wetlands, 13th Convention of the Parties in Dubai last October, in support of emerging Ramsar resolutions on climate change, with our co-author and SWS President Beth Middleton leading that effort. As a follow-on to our first paper, we wrote an article for the Conversation blog, and that's now collected over 62,000 reads, which is a lot of press for wetlands. And now we'll turn the webinar over to our first speaker, Bill.
Thank you, Jillian. I'm waiting for the slide to come up here. I can't, oh, there we are. Thank you. Wetlands in a Changing Climate, Science, Policy, and Management is the title of our paper. And as Jillian told you, this was a group of scientists. The asterisks indicate past, present, and former, past, present, and future presidents of the Society of Wetland Scientists. So I'm traveling here with a pretty high-powered group of wetland scientists as the climate scientist in the group. We all know that the world is changing dramatically, and increasingly there is a new agenda for wetland scientists and policymakers and practitioners as the climate changes. There is a role both for mitigation and for adaptation, resiliency, and I'll be talking about some of those aspects. Here is just an example. Here's a group of conservation commissioners. Every city and town of the 361 towns in Massachusetts has a conservation commission made up of citizens, and they are asked to respond to any development that might actually impinge on a wetland, and they too are now beginning to realize that they have a role to play in the policy realm when it comes to wetlands and a changing climate. So I'd like to give you just a little background on the climate change part of this, and then go through a more detailed example of how the emissions and sequestration rates differ and how they can be made to work together. So in 1992, at the Rio, sometimes called the Earth Summit, the 154 heads of state and heads of government all signed the United Nations Framework Convention on Climate Change. And Article 2 of that states very clearly, the ultimate objective of this convention is to achieve stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. That's a very clear and scientifically accurate statement. It's about the concentrations that we are concerned. It took until 2015, though, to get an agreement. We had an interim agreement, the Kyoto Protocol, which is actually still in effect, but it had some success in getting developed countries to reduce their emissions. But in 2015, a remarkable thing happened, and every country in the world, the developed and developing countries, agreed that they should do something to address climate change. So this agreement aims to strengthen the global response by holding the increase in the global average temperature to well below 2 degrees Celsius above pre-industrial levels, and we should make every effort to stay below 1.5 degrees. And so that now gives a definition to what dangerous anthropogenic interference is. And on the Eiffel Tower, while this was being negotiated, there was a statement there was no plan B. And then there was a that was the finishing phrase of Ban Ki-moon, the Executive Secretary of the United Nations: no plan B, and there is no planet B. That was what he said. It was a very powerful way to end a complex meeting that led to universal acceptance of this goal. Now, unfortunately, we've got a long ways to go. This is from a group called Climate Interactive that took all of the nationally determined contributions from Paris and put them on this thermometer. And if we had done nothing, temperatures would rise to 4.5 degrees Celsius or 8 degrees Fahrenheit by 2100. If we do what everybody says that they would do, we would be at 3.5 degrees. And yet the goals are the green area down there, 1.5 to 2 degrees, or no more than 3.6 degrees there, or 2.7 if it's Fahrenheit. So in November of 2018, the United Nations Environmental Program issued a report called the Emissions Gap Report. And it says current national commitments on emissions reductions are not sufficient to bridge the emissions gap in 2030. If countries do not scale up their ambitions before 2030, we cannot avoid exceeding the 1.5 degrees. And so we could see at least 3 degrees rise by 2100 with warming continuing afterwards. And then the Intergovernmental Panel on Climate Change put out a report, a special report on what will it take to reach the 1.5 degrees. And it basically says we have to reduce our emissions by 45% by 2010, our net emissions by 2010, from 2010 levels by 2030 and reach net zero around 2050. So that seems like a pretty big lift. The US had a climate assessment report which came out about the same time, which looked at some of the consequences of climate change. And it just says that it's being felt across the country, more intense and extreme weather, and future climate change is expected to further disrupt many areas of life, and these effects will not be distributed equally. And this is just showing some of the kinds of things. Every country can produce a document like this with similar results. Heat waves have increased since the 1960s to 2010, and our cooling degree days have gone up. We've had to use more air conditioning, and our heating degree days have gone down, the blue line, because it's not been as cold. There's been an intensification of weather and precipitation. It's not that we're getting more hurricanes and typhoons in the world, but the ones we are getting are more intense. And in 2017, the hurricane season in North America was just unprecedented. Dramatic changes in so many really intense hurricanes, and many of them dropping vast amounts of rain. In the case of Houston, it was something like 50 inches of rain in about in less than 2 days. So this is just showing the superstorm Sandy. Again, global warming is not a cause of anything. Global warming or climate change doesn't cause anything. Global warming changes the climate system, heats up the oceans, provides more energy for hurricanes, which is why they're more intense and intense storms. Precipitation events have increased a lot. So where I live up there in the northeast corner of the United States, between 1958 and 2012, there 71% more rain fell in the top 1% of precipitation events in 2012 than it did in 1958. And you can see other parts of the United States have seen increases, except for Hawaii, which has gotten drier. And this is quite a transformation of the weather systems, and that's led to flooding. And one of the reasons the floods are so bad is there's more intense precipitation, but also we've paved over more land. We have drained wetlands and forests, and that those would have provided greater resiliency. We would not have gotten the extent of flooding that we have. And of course, sea level is rising from the warming, and that's actually flooding coastal wetlands and destroying some of them. So wetlands challenges and opportunities. So all wetlands will be affected by climate change, and they'll release increased amounts of carbon dioxide and methane as temperatures rise. This realization was actually put forth back in the mid-1980s by George Woodwell, who's a forest ecologist and one of the leading people on to link natural systems to climate change. And so by protecting and restoring wetlands, we can help sequester additional carbon and reduce climate change because there will be fewer heat trapping gases in the atmosphere. I'll just run through this is just kind of a quick run through different types of wetlands. I mean, this is obviously a cypress swamp in the southeast US. Here's a northern freshwater wetland up in the northern part of the United States or Canada. Here is a southern freshwater wetland in the southern United States, a forested one. This is, we now jump up to the Arctic. This is what permafrost looks like. This is a frozen wetland, if you like. The soil is frozen solid for at least 2 years in succession. There are saltwater wetlands along the coasts. This is showing one type of a northern one. Here is another one. It's one of my favorite ones, not far from where I am along the coast of Massachusetts. Just a very large area of a tidal wetland in Essex, Massachusetts. In the tropics, there are saltwater mangrove wetlands, and these store a great deal of carbon. And then here is just a small freshwater wetland in the northeast United States. So here are some important facts about natural systems in the carbon cycle. So about a third of the carbon dioxide that's been added by humans to the atmosphere since 1750 comes from deforestation, wetland destruction, and land degradation. That always surprised me and others as well. We think of it all as coming from burning fossil fuels, but a full third of the carbon that's been added as carbon dioxide has come from natural systems that have been degraded. And on the other hand, an amount equal to 1/3 of annual fossil fuel carbon dioxide emissions is removed by natural systems on land every year. I'll show you how that works in just a moment. And a new finding just came out last year is that terrestrial ecosystems, forests, wetlands, grasslands, and soils are currently removing only about half as much carbon dioxide as they are capable. In other words, we have altered them in various ways so that they are unable to absorb as much as they can and to store it. And forests actually remove the largest amount, but it turns out that wetlands with only 5 to 8% of the land area store 30% of soil organic carbon, which is an amount that's greater than forests. So the main takeaway here on wetlands is they do not remove as much annually, but they have removed enough over the years that they store more than forests do today. So let's just run through this little exercise. This figure is from a paper by Corinne Le Carré and about 50 other climate carbon cycle scientists who each year assess the situation in terms of the carbon cycle, all the papers that have been published, and they put out a new version of this figure. And they then average it over the previous decade. So this is from the 2018 paper. The 2019 paper has not come out. So it's for the decade from 2007 to 2016. These are the average figures. There are about 850 gigatons, billions of tons of carbon in the atmosphere. If you look at the lower left, there's about 2,200 billion tons in soils, and that includes wetlands. There's about 10,000 gigatons in geological reserves. There's probably more than that. We don't really know, but that we could put more than 10 times as much in the atmosphere as we've already put into the atmosphere that is accumulated in the atmosphere to date. And if we look at emissions, I've just circled the emissions. There are about 9.4 billion tons that come from burning fossil fuels and industrial processes like cement making, and about 1.3 billion tons that come from land use changes. Now, you'll notice in this figure, they don't show any pictures of wetlands. They show forests and they show burning. Burning forest is a land use change. And that's a bit of a problem that climate scientists have. They do not fully appreciate the role of wetlands, but I'll get to that in a moment. So if we add together those two sources, that's 10.7. You see up there next to the sun, 10.7 billion tons. But interestingly enough, only 4.7 billion tons appear. So we're putting 10.7 in and only 4.7 increases. There's only an increase of 4.7 billion tons in the atmosphere each year. And so what is happening with the rest? Well, the rest is being removed by natural systems. The land sink, which again, they only show forests here, but it also includes wetlands and grasslands and soils, absorbs about 3 billion tons. The oceans absorb about 2.4 billion tons. And there's an unknown sink called budget imbalance of 0.6 billion tons. That well may be wetlands that aren't counted. It may be just parts of the world where there's perhaps more carbon dioxide fertilized growth than we know about. But anyway, the total removal rates are 6. So 10.7 minus 6 is 4.7, the amount that has increases in the atmosphere. So there it is. Total in 10.7, total removal 6, atmospheric growth 4.7. Now, the reason I show you this is because all the focus is on emissions. And I'm going to suggest why it's important to consider the removal rates, the sequestration rates as well. So I want to talk about closing the carbon dioxide sequestration gap. In the report by the Intergovernmental Panel on Climate Change, it says to achieve a limited increase of 1.5 degrees by 2100, we have to remove additional carbon dioxide from the atmosphere. That's called carbon dioxide removal, or CDR. And existing and potential CDR measures include afforestation and reforestation, land restoration, and soil carbon sequestration. All right, they don't mention wetlands. They mention soil, but they don't mention wetlands. Afforestation means planting forests where none are growing now, and reforestation means planting after you've cut forests. And the only mention of wetlands in the whole report, word appears once, is that they will emit methane as temperatures rise. Well, if we fill the sequestration gap, it shows these are a bunch of different scenarios in the left-hand figure, and you can see that they all cross the zero line somewhere around 2050. And that's when we have to have natural systems or other systems taking out more carbon dioxide than we put in. And on the right-hand side, it shows what happens to concentrations in the atmosphere. We can actually begin removing carbon dioxide, and here they show what that would mean in terms of temperature. And we could get, even though we rose up to 1.8 or more degrees, we could be back down below 1.5 degrees by 2100. So our wetland, how do they store carbon? Well, they store it mostly in the soils. This is a photo that I took when we went on the Society of Wetland Scientists field trip at the Denver meeting. We went up to 10,000 feet, 3,000 meters at a fen. And here are two scientists from Colorado State Universities. They brought along a coring shovel. And you can see in the right-hand side, they only go down to a couple of feet. And just look at the black dirt, the black soil there, the carbon that's in that soil. And the woman on the left is holding some of the surface vegetation, which keeps it cold. In fact, we were there the end of May, and this was ice cold to the touch, well insulated, so the carbon stays for a long time. Here is a saltwater marsh in Massachusetts, and with measuring equipment and so forth. And this again is a core from that. And you can just see how, and there's a boot for scale, you can just see how carbon rich that soil that soil is, and it's accumulated over long periods of time. Here's a photo of a coastal wetland along the Bay of Fundy in Maine. You can see it, the edge there. It goes, it's about 10 feet or 3 meters of soil, and it's been radiocarbon dated, and the bottom layer is about 3,000 years old. So this just demonstrates the very long time frame for carbon storage in wetlands. And from this paper by Murray and Pendleton and Sifley, you can see here the tons of carbon dioxide equivalent per hectare in different kinds of saltwater wetlands, and it compares it to tropical forests. And the brown is the soil organic carbon, and the green is the living biomass. And in tropical forests, at the bottom, most of it is in the trees, most of it's in the plants. But in these coastal wetlands, these saltwater wetlands, most of it's in the soils. And you can see for that oceanic mangroves take the prize in the amount of carbon stored per hectare. So comparing some sinks, if we burned all the fossil fuels, we'd add 12.5 times the current CO2 to the atmosphere. If we burned all forests, it would add about 6/10 to the more. And if we released the carbon, all the soil carbon, it would add almost 3 times to the current carbon dioxide. But forests rate a whole section in the Paris Climate Agreement, and they should do everything to appropriate for sinks and reservoirs of greenhouse gases. That's great, but then it only talks about forests. Reducing emissions from deforestation and forest degradation, and the role of conservation, sustainable management of forests, enhancement of forests, and carbon stocks. Oh, and by the way, do that in developing countries. And they will do things together, will manage forests sustainably, on and on and on, and get non-carbon benefits, but nothing about wetlands. And yet, in fact, taxpayers are subsidizing the burning of wood for heat and electricity in Europe and the United States. And there are regions of the US that have become major suppliers that have huge implications for forested wetlands. And yet burning wood is more carbon intensive than coal. To get the same amount of heat, if you burn wood and coal, the amount of carbon dioxide from burning wood is greater. And if you use it to make electricity, it's even greater still. So this is just showing North Carolina is now the epicenter of cutting forests, particularly wetland forests or forested wetlands, and sending the pellets to the UK. And this is just showing the power plant. Oops, sorry, skipped over that. And here you can see trucks. They claim that they're only using sawdust that's left over, but you can see these trucks coming from on the left, going right into the pellet plant. And on the right is what's left behind in terms of this wetland forest right along the river there. And this is just a ground level picture of what happens. This was a very nice forested wetland. It is now a forested stump land. And some of these places, it's just incredible the amount of damage that's done, and you can see the amount of runoff and erosion into the river. In Alaska, the Army Corps of Engineers has not even requiring any offsets to disturbances of wetlands. They said it's not a problem, it's so vast it doesn't matter. Others would disagree with that. On the other hand, we have some good news coming from the tropics. Here are in West Africa are various communities that are replanting mangrove forests that have been denuded for firewood, and in some places have been removed to create ponds for shrimp growing. So this is actually an NGO that I'm affiliated with, Earthwatch Institute, which works with volunteers to go on expeditions to work with people like this, or to visit places in the world to work on biodiversity, or in this particular case, replanting of mangroves. So let me just wrap this up and say that, and I won't say much about this because Max will talk about it. Wetlands now receive some attention, there's a 2013 supplemental guide on wetlands that Max will talk about. And so just again, wetlands are only 5 to 8%, but store 30% of soil carbon. They provide protection from flooding. They're important for biodiversity, and coastal wetlands and estuaries are the nurseries for marine fish. And there's this very strong asymmetry between the rate at which carbon is accumulated by wetlands and how readily it can be released in weeks or months, when it takes centuries to millennia to put it in. And so protecting wetlands is a high priority from a carbon point of view. Restoration is possible, but created wetlands take a very long time to begin sequestering carbon. Thank you. Max?
Thank you, Bill. But do I have control of? Yes, no, I don't have control of the slides yet.
You don't have control of the slides yet.
Mhm.
Let me see if I do.
Just flick to the next one anyway. So.
Yeah. Ah, there you are. Now, do you have control? I hope. Yes, I think you do. Yeah.
Yes, here we are. This one's fine. Thank you. Thank you, Bill, for the introduction to the issues. I want to now move this forward, and I still don't have control of the slides.
You have to go up to there.
Yes, I do.
Yep, there. You got it.
Okay, thank you. Technology. It is very early morning where I am. Sorry. What I'm moving it from. Bill's been talking primarily about the science of climate change or some of the scientific issues. I want to move more into the policy issues and explore the policy and management issues at different levels, international to national, and down to local, to help identify some of the strategies and policies so we can get an integrated understanding of both wetland and climate change science. One of the issues coming out of Bill's comments already are how do wetlands fit into our climate science and policy outcomes. And this is really about how do wetlands fit in the carbon cycle, how do they capture carbon, and do they retain carbon, and what sort of policy we need to actually encourage these activities. So if we move to the next one. When I'm doing this, I want to keep this within the context of wetlands globally. The Ramsar Convention last year put out a global wetland outlook, which is a state of the world's wetlands and their ecosystem services. And it just shows here that although still covering a large area of the world, 35% of wetlands have been actually lost since 1970. That is where we have data. We don't have data for all parts of the world, unfortunately, but still there's a major loss. So while we'll be saying here, wetlands are important for climate change issues, we're actually losing wetlands at a very, very fast rate. And therefore, if we're losing the habitats, the ecosystems, we're losing the wetland plants and animals as well. And many of them are moving towards extinction. So we could actually lose many of these species. At the same time, the quality of the remaining wetlands is also suffering due to a lot of issues that we've been trying to combat for many years, such as drainage, pollution, invasive species, etc., and now climate change. So within that, on the bottom right of this slide, at the end, I'll come back to put the climate change issue within the context of the second warning to humanity as it applies to wetlands, which Gillian mentioned earlier. So in the following, I've already said, we'll explore several examples of how international policy can influence management and protection of wetlands, including climate mitigation and adaptation and resilience benefits. Examples come from the Intergovernmental Panel for Climate Change, the UN Framework Convention for Climate Change, moving to the South Pacific Regional Environment Program, the North American Action Plan, and mainly the Ramsar Wetlands Convention. And in doing this, we want to also emphasize and keep in mind Wetlands are important for 3 of the United Nations Sustainable Development Goals that apply to all countries, covering climate change, life below water, and life on land, which just makes the point again that globally, wetlands are important, and climate change is an important part of our future management of wetlands. So, initial steps to incorporate wetlands into international climate policies are in place. We haven't, though, as Bill's already mentioned, moved very far compared to the forestry people. So in 2013, the IPCC, the International Panel, which provides guidance to countries on how to compile their national greenhouse gas inventories, released a wetland supplement. This is a major step forward because prior to this, wetlands were not considered under the IPCC processes. It wasn't considered because it was difficult or seemed to be difficult to, the actual science was seen to be difficult, that we didn't have robust methods for how to determine how to calculate the contribution of wetlands to greenhouse gases, or how much carbon was stored in wetlands. The issue being is that some wetlands under some conditions store carbon, and other conditions they can release carbon dioxide and methane to the atmosphere. So we have this duality, or this issue of where do wetlands fit in the carbon cycle, and then how do we set policy for that? So while this guidance provides some sort of advice, not many countries have actually picked it up yet. So, 8 countries have, based on peatlands as part of their nationally determined contributions. And I think we should be watching these countries. The fact they're doing it is a major step forward, but we need more than 8 countries to do this. So it's much further to go on this, but we do have a start. There are other mechanisms within the United Nations Framework Convention on Climate Change, where blue carbon in particular, this is the coastal ecosystems which store carbon, seagrasses, tidal flats, mangroves, as well as other wetlands, might be included in climate policies. The REDD Plus initiative, the reduced emissions from deforestation and degradation, the clean development mechanism, and nationally approved mitigation actions. There's a lot of acronyms in here. This is part of the UN process of trying to set up instruments, and everything gets its own little name. So, but these mechanisms, they're actually there, they exist, but they are focused more on terrestrial forestry projects. But they could include saltwater and freshwater wetlands if these projects can demonstrate the effectiveness of wetlands for emissions, which brings us back to the science. So we really need to get the policy and the science working together here. There is an opportunity to include wetlands, but we need further input from wetland interests and the Ramsar Convention on Wetlands itself. Note that in 2018, the Ramsar Convention, after a lot of talking over many years, did take steps to further address blue carbon. This is the coastal wetlands in carbon. So there is major movement on that front, but there is still major disagreement over whether a wetland convention should address climate change when there is a climate change convention. So we have this issue. We have a wetland convention. Climate change affects wetlands. Wetlands have to be adapted to contend with climate change. And we have a climate change convention, which Bill has already mentioned, hasn't in the past paid a lot of attention to wetlands. And yet some countries would prefer wetlands to be addressed under the climate change convention, which in my opinion has slowed down both the policy and the management front of wetlands. But it's not all bad news. I just want to show several examples here. The South Pacific, the Secretariat of the Pacific Regional Environment Program has set climate change as a priority under their strategic planning. It is a cross-cutting issue and comprises programs on adaptation, mitigation, policy, and science. It is a priority here because these islands in the South Pacific in particular are already disproportionately showing the effects of climate change. So a lot of these countries are under threat from climate change as we're actually sitting here speaking. So these countries have picked up these initiatives. They have engaged with the Ramsar Convention to try and, one, manage their wetlands, to protect their coastal systems, and to look at climate-related disaster reduction as well, mainly storms and sea level rise type issues. So there's strong interest in encouraging further international action on climate change in this part of the world. But to be successful, these small countries need to engage other larger and more wealthier countries. They cannot do them do it by themselves. In this area, though, there is also a high interest in blue carbon. So blue carbon is the one thing that, in my mind, that is really coming forward through the policy initiatives most recently. We just come back to North America. In 2016, the leaders of Canada, USA, and Mexico announced the Partnership Action Plan, which again explicitly identified blue carbon as an issue, but looked at the preservation and restoration of blue carbon wetlands as mitigation actions, and looked at the value of wetlands for climate resiliency. So it include the intention to enhance the conservation and restoration of wetlands, which would increase mitigation actions through blue carbon to preserve coastal ecosystem services and reduce the impacts of more frequent or intense storms or weather events. And this is an important thing. Bill showed the photograph of Sandy. These superstorms are present. Whether wetlands can mitigate the impacts, the total impacts of the storms is arguable, but they can reduce some of those impacts. So the Ramsar Convention is really where I wanted to focus this policy on. Since 1975, the Convention has provided an international framework for wetland management and policy. It comprises 170 countries. Generally meet every 3 years and agree on priority actions to support its mission. The mission is very, very broad. It is the conservation and wise use of all wetlands through local and national actions and international cooperation towards achieving sustainable development throughout the world. It's a very lofty goal. It's been around since 1975, and the Convention tries to implement this through 3 pillars of activity, which is the wise use or sustainable use of all wetlands, the designation and management of wetlands of international importance, the Ramsar sites, which is probably the most recognised part of the Convention, and to undertake international cooperation, especially for shared wetlands, which raise other issues of governance and management. So the Convention has in recent years recognised the significance of wetlands in managing global greenhouse gas emissions in addition to traditionally acknowledged ecosystem services. So this greenhouse gas mitigation issue is part of the overall ecosystem services from wetlands. So in 2012 and 2015, they agreed a number of actions, but it didn't really go very far. It took until 2018 to more specifically recognise the importance of wetlands and through the blue carbon issue. And interestingly, some of the interest in blue carbon and wetlands and blue carbon comes from the fact that there could be an economic imperative here. And I don't mean that just in terms of possibly making money from blue carbon wetlands, but getting money so you can actually manage the wetlands. So using various economic measures to put a price on carbon so you can actually get the money so we can manage these ecosystems, which we have been losing up until date. And are we moving? Yes, but unfortunately, the Convention, due to major disagreements between different countries, has not provided specific guidance on how to meet the wise use requirements under the Convention in the context of climate change. That is, climate change has a major negative impact on many wetlands. Not all wetlands in all parts of the world equally, mind you. But we expect climate change to exacerbate the current problems we have of managing wetlands. And to actually do this under the convention, we need to establish some sort of reference condition and monitoring program. You put climate change into this mix, then we have a major problem as to what is a suitable reference condition when the whole world around us is changing, and even do the historical reference conditions which underpin much of our legislation nowadays, do they apply in the future? So there are some major policy gaps here concerning how objectives and targets of wetland conservation and management could be set or revised in the light of climate change, how wetland management could best address the uncertainties due to climate change, meaning how much will wetlands change in the future, and whether adverse changes in ecological character, which is the term that the Ramsar Convention uses, if a change in ecological character due to climate change could be subject to the same reporting requirements as other drivers of change. This is really referring to, under the convention, countries need to report adverse change. Global change, such as climate change, is affecting all wetlands. Do we then want to report on all wetlands? I don't think it's practical in the end, but it is still there. In response to this, the Australian government, for example, has decided it would not use the existing formal mechanisms for reporting adverse change in Ramsar sites when caused by climate change, which raises a whole series of questions about the adequacy of the policy framework. It's a paradox. We recognise the vulnerability of climate change, of wetlands to climate change, but have not addressed the implications for the actual reporting and monitoring mechanisms, etc. We really need to address this situation. It's one of the issues that we really hope that the convention will pick up in the near future, under the fact that wetlands are being lost anyway. So I just want to move, there's a lot of text here. I want to move, this is just the thing that, if wetlands are so important for carbon storage, etc., or the carbon cycle, how much wetland do we really need to make an impact? If you drop to the end of the third paragraph here, the area of new wetlands needed to remove 1% using the figures I've already included here, to remove 1% of the current increase in atmospheric carbon dioxide. We need about 2 million square kilometres of new wetland, which is 17%, roughly 17% of the existing wetland area globally. There's a large amount of wetland to actually restore or create. We are far better off to maintain our existing wetlands so we can maintain the balance in the carbon cycle, and at the same time curb temperature rise to avoid releasing further greenhouse gases. So this is really saying, well, we can manage wetlands, we can create new wetlands or restore old wetlands, we can improve the carbon sequestration over time, but not equally in different wetlands. But it is still only a small contribution to the overall problem. So while wetlands are important, we need to manage other sources of carbon dioxide, etc. as well. Which really relates, are there new approaches to wetland management and governance, where in effect, can we generate private investment in wetland restoration and management by linking to various voluntary and compliance carbon markets? This is a vexed issue. Many countries are struggling with this, private generation, how do you put prices on carbon, etc. But there are mechanisms through the verified carbon standard, for example, which provides a means for managers and voluntary carbon market developers anywhere in the world to initiate, in this case for tidal or saltwater wetland, restoration programs for greenhouse gas credits. So we actually have got examples where we can actually use these mechanisms, use these policies. They just need to be developed further and applied more globally, and to overcome some of the more philosophical limitations to their implementation. So, and this is shown in the American Carbon Registry for 2017, etc. for the carbon credit methods for wetlands in the Gulf of Mexico and California. These are basically voluntary mechanisms, and it's important though to find out, while we have these mechanisms for carbon credits, we also need to address the best management practices so we can minimize emissions during freshwater restoration. We haven't gone into this in the past, but during our restoration processes, we can actually increase greenhouse gas emissions. This needs to be minimized while we're trying to encourage the actual storage or sequestration of carbon in wetlands. We understand the science, it's the management that I think we really need to get on here. Which brings us to the end. I'll mention that quickly because I just wanted to finish, and I'm noting the time as well. The second warning to humanity was a call by scientists to really, it's a wake-up call by saying we are pushing the planet too far in many aspects. So we switched this from a global view to a wetland view, and these points listed on the right-hand side of the slide from A to K, I'm not going to go through those, but we just sort of put the wetlands in this context, recognize that wetlands are important for people and that we're losing them at a fast rate. But we put this into the context. We have a problem with wetlands globally. The second warning to humanity raises these problems. Climate change is another layer over top of this, which is going to make our management of wetlands even harder. And we'd really want to try and see international instruments, policy instruments such as the Ramsar Convention, pick up these major issues to advise governments so governments can do the management. To finish, the management needs to be at the local and national scale. Internationally, international policy will not solve the problems at a national level, but international policy can help national governments implement policy to try and solve these problems. So thank you very much, and back to Gillian.
Okay, thank you, Max. I'll see if I have control of the screen. I'm not sure if I have. Let me try. Okay. All right. So I had one more slide, but I think it wound up in the middle of the presentation. Before we begin our Q&A, just wanted to share with you some of our next steps in drawing attention to wetlands in the context of changing climate. At the May 28th to May 31st, 2019 SWS annual meeting in Baltimore, Maryland, USA, we will be presenting a symposium on the critical role of wetlands in international climate solutions. And the exciting thing about this is that there will be speakers who will be both wetland scientists and also some from the climate policymaking realm in an attempt to build a stronger bridge between the climate policy and decision-making world and the wetland science policy and decision-making world. And then we're in the early stages of initiating another paper on key issues for wetlands and climate change involving the SWS interest section, and hope to introduce an aspirational statement for the annual meeting attendees to sign the Baltimore Proclamation, which follows our two earlier ones, the San Juan Statement and the Denver Declaration, that outline key priorities facing wetlands in a changing climate and allow the meeting attendees the opportunity to participate with their individual signatures. And then those statements can be shared with other entities. And we're a little short on time, but we have a couple of questions that I'm going to kind of combine the two questions. And I think probably, Max, you might be the best to address this. The question is interested in the potential for using wetland systems in the fight against rising global temperatures, because although many have been either filled or removed in the last 100 years, they're saying it's in hope that our restoration and mitigation work will have a positive effect. And the other person wanted to know, can we restore wetlands to their original appearance and function?
Ooh, thank you. I mean, wetlands play a major role in our local climate, and the large wetlands in particular do influence the climate. If you take the wetland out, you change that climate. So maintaining the wetlands in the landscape at a local level even can have a local influence on the climate, usually in terms of cooling and keeping it slightly more moist. So maintaining the wetlands there is, I think, an important aspect locally, and you add up all the local ones, you get a global outcome, obviously. But in terms of the restoration issue, we can restore wetlands, but it takes a long time to get back to anywhere near the actual same functions, the same extent, the same biodiversity, or the level of biodiversity, probably rather than the same there. So while we can do it, it takes a long time, and we're never quite sure we'll get the same. So we're actually better off to leave them there and manage what we have rather than have to create. Noting that where we've lost it, then we do need to create or start again. Thank you.
Okay. One more question. Does this question, what do you think about the culture, in quotation marks, proposition being tested by Bill Mitch's group to rotate land from crops to wetlands and back over 5 to 10 year cycles?
Jillian, that was hard to hear you on that. It was broken up. But...
There's some background noise. I don't know if anybody...
Jillian, let me go ahead and reread that real quick here. In relation to the climate change and wetland degradation challenges, what do you think about the culture proposition being tested by Bill Mitch's group to rotate land from crops to wetlands back over 5 to 10 year cycles?
Probably Max,
Jillian.
do you want to talk or yeah, go ahead, Bill, whoever.
Oh, go ahead, Max or Jillian.
I haven't actually, to be honest, I haven't caught up with what Bill and his colleagues are doing there, but I think if I understand the question, any process which helps us get more wetlands back into the system, even on a temporary basis, I think can be beneficial as long as we don't increase carbon emissions when we're changing between crops and wetlands. And I say that because not all wetlands are permanent. Many wetlands dry out naturally, so that flooding drying is an important issue anyway, which has various outcomes for the carbon cycle. But if we can get that managed and get more wetlands and more wet conditions with benefits for carbon in this case and other ecosystem services, then I think we should be trying it. But they do need to be tested. I actually agree with that one fully. And
can I just add to that there's a wetland, there are ways to do wetland restoration. So if an area was previously a wetland, that, for instance, re-flooding a drained wetland tends to help with the carbon storage, but it also depends on the site. And saltwater wetlands, if you create or restore them, they very quickly become net carbon sequesters. But it's tricky with a newly created freshwater wetland, which can release more methane and carbon initially.
Yes.
Yeah, and then eventually it will become a net carbon sequester. But there's a study by Scott Neubauer that showed it can take decades, hundreds to thousands of years to reach the switchover point. So I guess that's with freshwater wetlands. The caveat is to, like Max said, to study the situation and see, and just make sure. You may want to you may want to create a wetland for other reasons like flood control, but you may not get that initial carbon sequestration right away.
One of the big issues, we didn't go into the science of it, but when we're trying to restore wetlands to maintain carbon stores, we actually look at the soils. Bill did showed the figures where most of the carbon that is stored in wetlands is in the soils. So we actually need to manage those soils as much as the vegetation and the above ground aspects.
Yeah. Okay, maybe one more question. This question is, what's the difference between organic matter and organic carbon?
Let me take a crack at that. I mean, there's organic soils is referring to the set of chemical substances that are formed in those soils. Organic matter is just a more generic term, I guess, but it's really the material that it was that black stuff you saw in those photos I showed. It is, and it's very, from a chemist's point of view, it's rather ill-defined because it's a lot of it's many substances, and most of them are mediated by microbial organisms that both make it and then devour it. Not necessarily the same ones, but it's a complex interaction between soil microbes that really make most of that happen. Max, you want to comment further?
No, I think that's quite good. I mean, the organic matter, I think, just includes everything that's in the soil, whereas carbon is the actual carbon itself. It's as you said, it's part of the organic matter, and it's a far more accurate term than organic matter itself. Organic carbon, I mean.
I mean, I assume organic matter could include just grasses that haven't decayed. It could include sticks. It could include anything that contains. It was once a living part of a plant or an animal.
It could be the remnants of that moose you showed in your slide as well.
That's right. That's right.
Okay. Okay. Thank you. I think then just really quickly, we'll announce our next two webinars. We'll be holding our third Spanish webinar on March 27th at 2 p.m. and that'll be presented by Dr. Poi on fluvial paradigms. And then I have to move this forward one more. Our next regular SWS webinar will be held on April 18th, 2019, and we'll present one of our 2018 wetland ambassadors, Arohi Dixit, and her mentor, Dr. Tariq Munir. Our next webinar that is free and open to non-members will be on June 20th with Andy Sharp from East Coast Aquatics in Nova Scotia, talking about peatland restoration and the experience of practitioners influencing design and technique. We hope to see you at both of these upcoming webinars. Thanks again to Max and Bill for their great presentations and to you, our audience, for participating. Have a great day. Bye-bye, everyone.
Thank you and goodbye, everyone.
Thank you. Bye.